Commit your work to the Lord, and your plans will be established. Proverbs 16:3. Let us pray. Lord our God, in your wisdom and love, you surround us with the mysteries of the universe. Send your Spirit upon these students and fill them with the wisdom and blessing. Grant that they may devote themselves to the studies and draw ever closer to you, the source of all knowledge. We ask this through Christ our Lord. Amen. The secret to getting ahead is getting started. I congratulate you all for your in the next level, 9th standard. And this is your 9th standard physics textbook. I would like to give a small introduction about this 9th standard physics. ICSE board conducts board exams for 9th standard also. So this is very important in your life because basic topics for class 10th ICSE are covered in standard 9th ICSE. When it comes to preparing effectively for the exam, textbooks are the best source of material to study. The ICSE Physics Class 9 textbook issued by the ICSE board covers all the topics. So students should have a thorough knowledge of the physics textbook so that they can attempt final question paper with full confidence. ICSE Physics Class 9 is a quite vast subject, and the set of questions asked in the board exams are also quite difficult when compared to the other boards in the country. Textbooks for ICSE Class 9 have always been the storehouse of knowledge, and students should refer these books for a better understanding for each topic. Physics books are very important. The chapters that are covered in the ICSE Class 9 physics books are measurement and experimentation, motion in one dimension, laws of motion, fluids, heat, light, sound, electricity, magnetism, and so on. While preparing for the exam, students should always practice numerical, which are given at the end of each chapter, and related questions which are given different reference book. It would help them to score better marks in the board exams.
Children, I am your physics teacher, Mrs. A.J. Sheba. For the past 3 years, you all were very good. I am expecting the same this year also. I wish you all the best. Let us get into the class.
All measurable quantities are known as physical quantities, such as mass, length, time, current, and temperature. They are also known as fundamental quantities. To measure these quantities, we use different types of devices in different situations. The smallest quantity that can be measured with a device or an instrument is called the least count of the device. Some instruments that we use to measure length are the vernier caliper, ruler, and meter tapes. Similarly, we measure mass with the balance, time with the stopwatch, and current with the ammeter, and temperature with the thermometer. The vernier caliper can measure up to 0.1 mm or 0.01 centimeter, while the plane scale or the ruler can measure up to 1 mm or 0.1 centimeter. The devices that are used to devices mass are the common balance, digital balance, and analytical balance. The digital balance can measure up to 0.001 gram. You must have seen this balance in jewelry shop. A common balance can measure mass up to 1 gram, and it is commonly used in grocery shops. There are devices used to measure time, such as alarm clock, digital clock, and atomic clock. Atomic clocks and quartz clocks are used to measure time very accurately. For example, it is used in athletic meets and in some experiments. There is a new invention too, an optical analytical clock that takes 1 million billion times of every second and at least 20 times more stable of that current atomic clock. All clocks consist of two basic mechanisms, one with the device called an oscillator, which produces periodic events moving the needle every second, and the second one for counting and displaying the time. The clocks that you have at home can measure time accurately up to 1 second. The ammeter is used to measure current. Nowadays, the multimeter is used to measure current up to 0.001 amps. This is the image of optical atomic clock. I wrongly mentioned as optical analytical clock. And this optical atomic clock is the new invention. It is used to measure the time very accurately. Similarly, there is a device called the thermometer, which is used to measure the temperature. Clinical thermometers and many electronic thermometers are usually readable to 0.1 degrees Celsius. Special instruments can give readings to 1000 of a degree. Thus, these devices are used to measure physical quantities accurately. Vernier calipers is an instrument which is most commonly used in physics lab to measure length for small object accurately, which is not possible with the meter scale. The word caliper means any instrument with two jars which is used to determine the diameter of an object. Vernier caliper was invented by a French mathematician Pierre Vernier in 1631, and thus the name Vernier caliper has come. It consists of a long rectangular metal strip. It has a fixed jar at one end. It is graduated in inches in the upper end and centimeter at its lower end, which is called the main scale. There is a movable rectangular metal strip which is graduated in a special relation with the main scale, which is called the vernier scale. It slides over along the long metal strip. It has a jar similar to that of the main scale. These jars together are used to hold the object firmly by measuring its length, which is not possible with the meter scale. These jars are called external or lower jars, which are generally used to measure the diameter of a sphere or a cylinder. These jars are extended to the other side, called the upper or internal jars, which are generally used to measure the internal diameter of a hollow cylinder. There is also a metal strip attached at the back of the vernier caliper, which is used to measure the internal depth of a cylinder. Now let us see the working principle of the vernier caliper. A scale cannot measure objects which are smaller than 1 mm, but a vernier caliper can measure objects up to 0.1 mm. What is the working principle of the vernier caliper? A vernier caliper has two scales, the main scale and the vernier scale. Together, these are used to measure the very small distances like 0.1 mm. Here, the main scale has a least count of 1 mm and the vernier scale has a least count of 0.9 mm. So 10 units of main scale are 1 centimeter, whereas 10 units of vernier scale are 9 mm. So 1 mm minus 0.9 mm is equal to 0.1 mm. This difference is called the working principle. Now let us see about the least count of the vernier caliper. The smallest digit on the main scale, we know that the smallest digit is 1 mm.
that should be divided by the total number on the vernier scale. And in this picture we can see the total number on the vernier scale, that is 10 division. Now you have to substitute these values in the formula, that is least count is equal to the smallest digit on the main scale divided by the total numbers on the vernier scale is equal to 1 mm divided by 10. You will get 0.1 mm or 0.01 centimeter. Now let us learn about zero errors in vernier caliper. You need to check whether the instrument is error free. Bring the two external jars J1 and J2 in contact. If the zero of the main scale coincide with the zero of the vernier scale, then the vernier calipers is free from error. In this condition, the tail of the vernier caliper just touches the end of the main scale strip. If the zero of the main scale does not coincide to the zero of the vernier scale, then the vernier calipers is said to have a zero error. There are two types of zero errors. They are positive zero error and negative zero error. With the two external jars in contact, if the zero of the vernier scale is on the right side of the zero of the main scale, then the zero error is said to be positive. The error is equal to the distance between the main scale 0 and the vernier scale 0. If the zero of the vernier is to the left of the zero of the main scale, then it is said to be negative zero error. This error is equal to the distance between the main scale reading and the vernier scale reading. Now let us calculate zero error. What is zero error? Zero error in the vernier caliper is a mathematical error due to which the zero of vernier scale does not coincide with the zero of the main scale. Let me show you. Here two scales are given. This is main scale and this sliding scale is vernier scale, and there are two jars. These two jars, this one and this one. When you bring these two jars together, now you can see these two jars are perfectly in contact. Then this zero, this is a zero of the vernier scale and this one is a zero of main scale. You can see they don't coincide. Ideally they should coincide. That means these two zeros should be equal, but they are not in the straight line. They don't coincide, so this kind of error is called as zero error. So whenever we found a zero error in a vernier caliper, we need to calculate this so that we can correct the final result. There are three cases of zero error. Here is the first case. When you bring these two jars together, so now you can see zero of main scale is coinciding with the zero of vernier scale. They are exactly in a straight line, so this vernier caliper is free from zero error. Or you can say there is no zero error in this vernier caliper. Second case is, let's bring these two jars together. You see the zero of vernier scale is ahead of main scale 0, or you can say 0 of vernier scale is at the right of main scale 0. In both cases, either it is ahead of main scale or it is right of main scale 0. This is called as zero error and it is positive zero error. Let's calculate it. So to calculate it, first we have to find the coinciding vernier scale division. So we need to figure out a vernier scale division which coincide perfectly with any main scale. So here let's check first vernier scale division. It's not coinciding. Second, third,
you can say third vernier scale division is perfectly coinciding with the main scale division. So this is 1, 2, 3, third division. So you have to write 3. Now to find zero error, multiply this coinciding division to the least count. So 3 times least count of vernier scale is 0.01 centimeter, which we found in the last video. So 0.03 centimeter. It's a positive error, so it will be positive. So we have to put a plus sign before the number. If it is positive 0 error, we have to put a positive sign before the number. So plus 0.03 centimeter is a 0 of this vernier caliper. Let's see the third case. First we will bring the two jars together. Here you can see 0 error of vernier scale is backside of main scale 0. To the left of the main scale 0. So if vernier scale 0 is either backside or to the left of the main scale 0, in both the cases 0 error is negative error. So let's calculate it. Again we have to figure out vernier scale division which exactly coincide with any main scale division. So here let's check first vernier scale division, second, third, fourth and fifth. You can see the fifth vernier scale division is exactly coinciding with the main scale division. See, exactly in this line. So coinciding vernier scale division is equal to 5. Then we'll find the difference of this. Total number of division minus coinciding division. Total number of division on vernier scale division is 10 and coinciding division is 5. So we got difference 5. Now we multiply this number with the least count. So 0 error equal to difference into least count. Difference is 5 and least count is 0.01 centimeter. So we got 0.05 centimeter and this is negative error. So we'll put minus sign before the number. So minus 0.05 centimeter is 0 error of this vernier caliper. Please note here, when we find positive 0 error, then we directly multiply coinciding vernier scale division to least count. But when we are finding negative 0 error, first we find the coinciding vernier scale division, then we will find the difference and then multiply this difference to least count. So there is a little difference between calculations. So you need to keep this in your mind. This is a tabular column for calculating the length of any object using the vernier caliper. First you have to write the least count of the instrument, that is 0.01 centimeter. Then you have to write the 0 correction. If there is any 0 error, you have to do the calculation. Then you have to write the main scale reading and the vernier scale reading. Now let us see how to find that one. Now let us see how to calculate the main scale reading and the vernier scale reading from this diagram. Here the reading on main scale is equal to 0.3 centimeter because 0.1, 0.2, 0.3 of the main scale coincide with the 0 of the vernier scale. Just like that, the vernier coincide 1, 2, 3, 4, 5, 6, sixth line coincide with one of the main scale. So main scale vernier scale reading is 6 and you have to multiply into the least count, that is 0.01. So you will get reading on the vernier scale is equal to 0.06 centimeter. To find the total length, you have to add both the main scale division and the vernier scale division. So you will get 0.36 centimeter. Now let us see another example. In this diagram, the reading on main scale is equal to 1.2 centimeter because 1, 1.1, 1.2 of the main scale coincide with the 0 of the vernier scale. So the main scale reading is 1.2 centimeter. Now the reading on the vernier scale is 0.03 centimeter. Here in this picture, 3rd line of the vernier coincide with the main scale. So here the vernier coincide is 3. You have to multiply with the least count 0.01. So you'll get 0.03 centimeter. You have to add both and get the answer 1.23 centimeter. Now let us see some questions given in your book. Explain the meaning of the term least count of an instrument by taking a suitable example. The least count of an instrument is the smallest measurement that can be taken accurately with it. For example, if an ammeter has 5 divisions between the marks 0 and 1 amps, then its least count is 1 divided by 5 is equal to 0.2 amps. Or it can measure current up to the value of 0.2 accurately. The second question, a boy makes a scale with a graduation in centimeter on it, that is 100 division in 1 meter. To what accuracy can this scale measure? How can this accuracy be increased? Total length of the scale is equal to 1 meter, and that boy makes a scale with graduation in centimeter on it, that is like 100 division. So number of division is equal to 100. Length of each division is equal to total length divided by total number of division. What is the total length of the scale? 1 meter, that is 100 centimeter, divided by number of division 100. So if you divide, you will get 1 centimeter. Thus, this scale can measure with an accuracy of 1 centimeter. If you want to increase the accuracy, then the total number of division on the scale must be increases. Suppose here the total number of division is 100. If you increase to 1000, then the accuracy also increases. Now let us see the third question. A boy measures the length of a pencil by a meter rule and expresses it to be 2.6 centimeter. What is the least count of the meter rule? Can he write it as 2.60 centimeter? The least count of the meter rule is 1 centimeter. The length cannot be expressed as 2.60 centimeter because a meter scale measures length correctly only up to 1 decimal place of a centimeter. Now fourth question, define the least count of a vernier caliper. How do you determine it? The least count of a vernier caliper is equal to the difference between the values of one main scale division and one vernier scale division. And later on we see how to determine the least count of a vernier caliper. And this question is important question. The least count of a vernier caliper, you have to by heart it and write and see. Now the next question is, define the term vernier constant. Vernier constant is equal to the difference between the values of one main scale division and one vernier scale division. It is the least count of vernier caliper. It is otherwise called as the least count of a vernier caliper. And you know what is the least count of the vernier caliper? 0.01 centimeter. Otherwise you can say 0.1 millimeter. Now the next question is, what is a vernier caliper said to be? When is a vernier caliper said to be free from zero error? I already taught this. A vernier caliper is said to be free from zero error if the zero mark of the vernier scale coincide with the zero mark of the main scale. The zero of the main scale should coincide with the zero of the vernier scale. Then the vernier caliper is said to be free from zero error. Now the next question, what is meant by zero error of vernier caliper? How it is determined? Draw a diagram to explain it. How is it considered to get the correct measurement? Actually, it's not clear here. Okay, due to mechanical errors, sometimes the zero mark of the vernier scale does not coincide with the zero mark of the main scale. Then the vernier caliper is said to have zero error. A new device does not have any error, but other device must have error. So that error divided into, there are two kinds of error. One is positive zero error, another one is negative zero error. and I taught more about the positive zero error in the videos and also about the negative zero error. On bringing the two jars together, the zero mark of the vernier scale is on the right side of the zero mark of the main scale, then the error is said to be positive. So just like that, you have to write the negative error. Now the 8th question is, a vernier caliper has zero error of plus 0.06 centimeter. Draw a neat label diagram to represent it. And before drawing the diagram, you should keep two things in the mind. Here it is mentioned plus 0.06 centimeter, so it must be a positive zero error. So the zero of the vernier should be to the right of the zero of the main scale, and also the second thing, the vernier coincide, that is the sixth line of the vernier should coincide with the main scale. Just seeing in this picture. It should be very clear while drawing, and also you should mark the parts and also the coinciding division so that it should be clear. The next question is, draw a neat and labeled diagram of a vernier caliper. Name its main parts and state their function. Here is the diagram. Draw neatly and mark the parts. And now the next question is, state three uses of the vernier caliper. Three uses of vernier calipers are measuring the internal diameter of a tube or a cylinder, measuring the length of an object, and the third one is measuring the depth of a beaker or a bottle. These are the uses of a vernier caliper. Now let us see the continuation of the 9th question. Main parts and the function of a vernier caliper. The main parts are the main scale, vernier scale, outside jars and inside jars. And main scale, it is used to measure length correct up to 1 millimeter. And vernier scale, it helps to measure length correct up to 0.1 millimeter. Outside jars, it helps to measure length of a rod, diameter of a sphere, external diameter of a hollow cylinder. And inside jars, it helps to measure the internal diameter of a hollow cylinder or pipe. These are the main parts and the functions of the vernier calipers. The next question is, name the two scales of a vernier caliper and explain how it is used to measure length correct up to 0.01 centimeter. Two scales of vernier calipers are main scale and vernier scale. The main scale is graduated to read up to 1 millimeter, and on vernier scale, the length of 10 division is equal to the length of 9 divisions on the main scale. Value of 1 division on the main scale is equal to 1 millimeter. In question 13, name the parts of the vernier caliper which is used to measure the following. The external diameter of a tube is measured by the outside jars, internal diameter by the inside jars, and depth of the small bottle is by the strip at the back side of the vernier caliper, and the thickness of a pencil is measured by the outside jars. And these are the questions. Please put a separate note and write down all the questions. Learn now and then so that it will be helpful for you. Thank you.